Alright, so my name is Ali Toho. This is the Ros2 project. So we have a control node. This is a robot. We give it a specific destination, so say ask it to move to here. Once I click on that point, it instantly moves and tries to go to that point. Um, Suppose I wanted it to move to a different point. I just click on it and then it will try to orient itself to move towards that point. Um, if it had to go through an obstacle, like say um, somewhere over here, it wouldn't fare so well because it currently does not have the ability to avoid obstacles, so it would hit the wall as we see in the camera. I probably have to guide it by moving it a little bit back and then a little bit towards this side, and then so sort of guide it towards how it would maneuver itself to reach to the point that I would like it to reach to. The way it kind of works is we have a subscriber. The subscriber gets all of the current information about the position of the current position of the robot. We have a transformer buffer and a transformer listener. So what the transformer does is it sees the global axis, global frame of reference, and the local frame of reference of the robot, and it gives us the sort of mathematical disparity between them so that we're able to transform a point. So that this point, when I click on it here, instead of it saying, for instance, negative, I don't know, negative, or if I was to, take a point here, assuming this is the positive x and positive y, a point here would be like, I don't know, -1, -10. But from the frame of the robot, if the robot was the origin, this would be like a positive point. So it does the math for us to give us the point given or in the frame of reference of the robot, and the publisher then takes this control information, this where we need to be going or where we need to go, and it gives that information to the control to actually move the robot, kind of like how these buttons allow us to move the robot, but through the actual commands of the linear and angular velocity. And we have a timer that runs every 100 milliseconds. So that timer callback will sort of get the transform the point of the current goal into the transformed point. We use a PID, so we're actually using a simple proportional controller, applying KP linear, KP angular onto the linear commands and angular commands to get the linear and angular velocity. Then framing those in the context of a twist message, because that's the data type that the twist message publisher takes. And so we send that every 10 milliseconds, we send the robot the sort of command of how fast it should move linearly and in the angular velocity. And that sort of allows us to move the robot in a path towards the goal or towards the target. Um, and yes, this is the control node, this is the timer node, um, this is the HPP file for the control node, and we're done. Thank you.